Good morning, everyone. My name is Uday Krishna. I'm studying MTech first year at IIT Kharagpur from CSC department. So the master thesis project title goes as follows: Fraud detection in Mule accounts using graph neural networks and graph attention networks. So the presentation outline goes as follows: problem statement and motivation, followed by knowing what are Mule accounts, and then why we use graph-based detection to detect the Mule accounts, graph neural networks, graph attention networks, and the data set used in the project. So the challenge on if this project is financial fraud is a massive global issue. Losses exceed $40 million annually. The major problem is out of all the accounts, mule accounts are less than 0.5%. It becoming very challenging to detect those accounts out of all, but the fraud cases involve 70% of these mule accounts. The problem statement is to detect mule accounts in a bank by analyzing account transaction logs using the graph neural networks, GNN, and graph attention networks. So let us know what is a mule account. A mule account is a legitimate bank account used to receive, hold, and transfer stolen money. Basically, a mule account can be a normal bank account that is used to receive, and then it holds some time, and then it would be forwarded to the other accounts in a very small amounts. The flow goes as follows. The mule account receives some stolen funds or some theft funds, and then it holds for some time that can be minutes to days, and then it is forwarded to another account. So the key patterns that can be found from these transactions are fan in or fan out, multi-hop chaining, circular routing, aggregators, layering chains. These are some patterns that can be used to find the mule account characteristic. So why to use graph-based detection to find these mule accounts? The basic traditional ML learning fails here because it reads each transaction independently and cannot see relationships between accounts. This is the fundamental thing that missing using machine learning. We use graph neural networks to find the patterns across the transactions, and we can detect them easily. In these graph neural networks, the model accounts acts as nodes and the transaction between the accounts are taken as edges. We aggregate them to form multi-hop neighborhood signals and captures the fan-in or fan-out topology and detects the layering through path embeddings, learns community structure of fraud rings. Graph neural networks. The core idea for using graph neural networks are the graph neural networks work using a concept called message passing. So the each node collects information from neighbors, combines it with its own features, and updates its representation. After multiple layers, a node understands its k-hop neighborhood. For example, GCN. GCN works by simple averaging. Graph stage works by scalable sampling. GAT uses attention. So the main idea in this project is to use GAT. Now let us know what is graph attention networks. Graph attention networks. These improve GNNs by assigning importance weights to neighbors. Instead of treating all neighbors equally, it learns which transactions are suspicious. The steps that follows by GAT are: it computes attention scores, it normalizes using softmax and weighted aggregation. It does not consider any irrelevant neighbors. It focuses on suspicious interactions and it provides interpretability. This is crucial because mule accounts are often hidden among legitimate ones. As we have already seen, it's the percentage is very less. It is less than 0.5%. So it is very important to extract pattern to detect those mule accounts. So let us know how the data is represented in GAT. The notes are taken as unique bank accounts, and the edges between the notes are considered when there is a transaction from one bank account to another bank account. Uh, the features that can be extracted are in degree or out degree, that means the fan in or fan out, the forwarding behavior, the transaction velocity, and the circular routing. These features directly encode fraud patterns. Using the GNNs, we extract these patterns to detect the mule accounts. So the dataset used is spacing dataset. It is taken from Kaggle and it has 6.3 million transactions which are simulated in 30 days. So the fraud rate is 0.13%. The fraud types are transfer and cash out. The transaction types involved in the dataset are cash in, cash out, debit, payment, transfer. The additional datasets that can be included in the project are IBM AML dataset, elliptic Bitcoin transactions history dataset, credit card fraud detection. So the evaluation strategy used for this project is AUPRC, F1 score, and FNR. Why not accuracy? Because if we label everything as normal, we get 99% accuracy but zero detection. As we know that there is less than 0.5% mule accounts, a classifier predicting benign for everything achieves greater than 99.5% accuracy. We need precision and recall focused metrics. So we considered AUPRC, area under precision recall curve. This is considered to be the primary metric. It directly measures the quality at the minority class, more informative than ROC AUC for imbalanced tasks. And the second metric is F1 score. It is the harmonic mean of precision and recall. It is reported at multiple decision thresholds to expose the precision recall trade-off for different risk appetites. And third one is false negative rate. False negative indicate the predicted is negative and the actual is false, positive. That means the chances of failing the mule account detection. A missed mule is a compliance failure. False negative rate is treated as a hot constraint. We treat FNR is less than 5%. As we have seen the data set, it has a very class imbalance. We can handle this class imbalance using focal loss. We downweights using negatives, focuses gradients on hard mule examples. Graph over sampling. It synthesizes mule subgraphs via smart style augmentation on graph structure. Cost sensitive training. Higher misclassification penalty for false negatives. So this is the basic idea of fraud detection in financial transactions using GNN and GAT. I hope you understood the presentation. Thank you.